Hey, welcome everyone. This is the first video in this series where we'll be designing a simple C++ Pac-Man game. Uh, what we want to do with this is have a console-based Pac-Man game that we can write under like 1500 lines or so. So to begin with, let's just start by designing the classes for the Pac-Man game. So the classes that we are going to use are the first one will be, of course, the main entity, that is the Pac-Man. The other one should be ghosts, and let's also use a class called games board, which will represent the game board, and we'll also use a class called game state, so this will represent the state of the game. And let's also use a class called palette. So a palette is either going to be a regular one or it is going to be a power palette. And finally, let's use a class called game. So this is going to be a driver class. Right. So let's start by writing some code now. So let's start by including some headers first. This is the basic C++ IO library or a header. Let's also use C++ std vector, which will allow us to store some of the especially the game board and some of the other data structures. Even though this is not the best practice to use namespace as standard, but we're not going to have any namespace of our own. So, and besides, this is going to be a simple program which is not going to have lots of namespaces and some of the advanced C++ features. Seems like this has crashed. Let's get it. Fine. So let's just start by defining our classes. So our first class would be, let's call it game state. So we're just declaring these classes first. Also write a game board class. Let's write the Pac-Man class. Let's write the ghost class. Sorry about that. Let's write palette and the game driver class, right? Now let's just start by defining our game board class first. We'll define it. Let me out here, VS Code. So our private variables are going to be the rows and columns of the board, which is fairly obvious. And let's also use the main board, the data structure. We'll define its entity in just about a while. So let's just define the board variable, and let's now define what the board is going to store. So let's instead of simply storing characters, for the sake of convenience, we'll store it as an enum cell type. Just makes it so much more consistent, and it makes it easier to read and easier to work with, because well, characters all over the place is going to make a mess. Let's say an empty cell. So a cell could be an empty cell, right? It could have a wall, could have a palette. Now this palette is going to be a simple palette. And it could also have a power palette. T stands for type, so anything empty, T would mean empty type, wall type, palette type, and power palette type. So naturally would mean Pac-man type and ghost type. So we have our enum defined here. Let's use it with forward. And now let's go and write our private methods. So let's first, one of the important things we want to do is get a character by the cell type. So let's write get character by cell type, and we'll get the cell type. Let's use a switch statement because if else would just make it. It's not a good practice to use if else where only one of them is going to be true. And I mean, this is just a good practice to use switch statement wherever we can, wherever there are multiple things to choose from and only one of them is going to be true. So let's say cell type is empty type. If that's the case, so let's simply return an empty character. Let's simply return an empty character here. Cell type, if it's a ghost type, then return G. If it's a Pac-man type, return capital P. If the cell type is palette, you simply return a dot, got a semicolon over there. Cell type, if it's a bar palette, and simply return a hash symbol. And what remains? Ghost is done, palette is done. Right, no, a bar palette, let's just give it as capital O. So we are remaining with the wall type, right? So let's use the wall type and return, let's call this as a wall. Great. Anything else is unexpected, so the default type, let's give an assert here because this, it should not come at this place. Let's say unknown cell type requested. Yeah, this looks fine. To use asserts, let's also include our appropriate header. So that would be assert.h. What is wrong with IOStream? Okay, this should be fine, I guess. Let's just try to build our program for once, and let's just make sure that there are no compiler related errors so far. Let's use the GCC compiler. Why isn't it auto-completing it? Okay. That would be .cpp. Let's use an O3 optimization level Pac-man Okay, no such file or directory. Okay. Okay, let's go inside Pac-man. Let's try to build our program once again. Should build just fine. Yes, it does. That's good. So after we are done defining the private variables and one of our private methods, let's now move on to defining some of the public methods in this class of game board. Okay, so let's just first get its constructor defined. So game board, let's just say it takes rows and it takes columns, so it's going to take the dimensions of our game board, and let's say will be the rows, user requested number of rows and user requested number of columns. And what else do we want? Okay, so we want reinitialize the board. So because the board here over here is empty, so this is just an empty declaration of a vector of cell type. So this is just an empty board right now. So we want to allow it to be the user requested dimensions. So board dot resize number of rows, and let's cell type the number of user requested columns, and we will initialize it with an empty cell. Great. So let's just, so this is, we're done with our constructor, game board constructor. So we are just going to have our own constructor and not a any default constructor. So one of the first things that we would like to do is to try to render the board. And this is going to be using a const qualifier because it's not going to mutate or change any of the board variables or any of the board characters. So we want to make sure this method does not change anything with respect to our board. So we have, this is just simple. We'll run over all the rows and columns and just try to print whatever's. Okay, let's now get use our get character by cell type. So this is what it's going to do. So our board is going to store a cell type variable, and we'll just get the character by cell type. So this is how our define method is going to be useful for us. So it's not going to print anything as of yet because it's all empty. Right, so we'll be using it in a while. So now let's define some more methods here for verification purposes. Like, let's say if a cell is valid cell, and we'll take it as int x and y. So ideally we should be using int, we should be using an unsigned because, well, we don't want our integers to spill over and become negative. I mean, our board dimensions to spill over and become negative or anything else, or spiral out of control. So this just it's just a good practice to use unsigned instead of it. So let's just first give an assert. Okay, not insert actually. Let's simply return these are valid and okay, less than rows and y is greater than 0 and y is less than false. So let's also use one boolean variable to understand when our board has been initialized. So let's say initialized. Okay, we don't want to define it here itself. Let our constructor do that. Should be true. Right. So we also want to make sure here that has been initialized before we're trying to check if it's a valid cell or not. Initialized, and let's just give a prompt letting the user know that you're trying to access a cell, you're trying to check a cell's validity when you have not even initialized it. So let's give a prompt saying board is uninitialized. Right. Pardon me for any of the spelling mistakes I make here. Let's also write a method to update our cell, update a cell. So we'll take unsigned x and unsigned y, and all it does is board of x and y is equals to whatever the cell type. Okay, you need to update it with certain cell type, so we'll also have to take a cell type variable in, and let's initialize the board of xy by the cell type. So before we do that, we need to make sure that this is a valid cell, and let's assert is valid cell x and y, and let's give a message that we're trying to update an invalid cell. Trying to update an invalid cell, that's nice. So one of the other things that we want to do is get entity add. So we want to check, given a location on a board, given a board coordinate, what is the entity at that location. So let's say get entity at unsigned x and unsigned y. Again, let's make sure that we are accessing a valid cell. So I'm just going to copy paste this assert over here and trying to access an invalid cell. So if that assert does not hit, all we'll do is return whatever is the entity sitting at that coordinate. This looks great. Let's again try to build it, make sure there is no build errors. Okay, there are a few. So what is it saying? Discards qualifies. So what is this talking about? So get character by cell type. So we're expecting passing game board has this argument discards qualifies. What is this trying to say? Board. So we have a board variable here. Should equal to get board by, what is this trying to say? Const. Okay, so okay, this should be marked as const because it says that you can't, because it's trying to read from the board, right? And you're making sure that it does not modify, even though it does not modify the board contents directly, but it's still trying to access it, and I think that's what it is complaining about. So this should be fixed, I guess. Let's try to build it again. Yeah, works. That's right. So let's move on to, let's try to get the number of rows. This might be helpful. Getter and setter methods could be helpful later on. And it just makes sure that if you want to access something from outside the class, which is a private variable, to the class. So let's get calls. Let's try to return calls, and let's say we also check for if the board has been initialized. Is okay, so it already checks there. We need to check if it's initialized, and board was not initialized. The same thing with get calls. Yeah, this looks fine. So I think that's about our game board class. So we have all the necessary methods in our game board class for now. Now let's go ahead and try to implement our game state class. So we'll come to Pac-man and Ghost classes later on, because they're not going to be trivial to implement, at least as trivial as game board, something like a game board or a game state. So let's define our game state class, and we don't have any private variables for this, so let's just move on with our public entities of game state class. So one of the first things game state is going to encapsulate is the game board. So it's going to be a game board. Let's define it as a pointer to a board. Let's also have a pointer to the Pac-man. And a game state is going to also contain a vector of ghosts. So this is where we are going to track how the ghosts are moving, or at least a bunch of ghosts together, and that's going to be a pointer to a vector which we are going to initialize by ourselves initially, and then later on we'll try to generate a maze. So we'll try to generate a initial game state by using probably we're going to use some of the algorithms to generate maze generation algorithms. So those algorithms can be modified to generate an initial game state, but to keep it simple enough, initially we are just going to hard code whatever is the board state that we are going to begin with. So with that said, let's write our game state constructor. So game state constructor is going to let's take a game board, because we have defined all of these as user pack and a vector of ghosts. So this is also going to be a pointer to define ghosts, right? Now this is supposed to be U-board. To make our code consistent, let's make this as capital cases, and our this dot ghosts is going to be U-posts. This dot we have a board, and let that be U board. So these are just pointers, so it's memory efficient to we're not going to duplicate any large data structures. That makes it much more easier to deal with. It makes it much more memory efficient, although it also makes it quite vulnerable if we happen to have any rogue pointers coming in. And apart from that, well, that's it. We just want to initialize, keep the game state as simple as possible for now. Now let's move on to some of the other classes, and we're going to implement Pac-man and ghosts later on. Let's first do the simplest of things, that is a palette class. This is going to be, oh come on. So we'll have a private variables for palette, not just a variable. Let's have where it's located, so rows and calls, and what is the type of the palette. Right, so let's define palette type as a enum. That'll be much easier to keep track of. It becomes and it's also good coding practice not to use constant characters or constant integers in your code within your functional code, right? So let's define an enum class palette type. We'll have two kinds of palette, that is a regular palette and a bar palette. So a regular palette will have a cost of 1, that is when a Pac-man consumes the regular palette and the score is going to increase by 1. If it consumes a bar palette, its score is going to increase by say 50. This is a standardized number that's used when Pac-man consumes a bar palette. Great. So let's move on and implement our palette type class here. So a palette is also going to have a type. Let's just say it's a pty. That's going to be the palette type variable. Public. Let's define its constructor. Let's say its row and call is given, and also the type is given. Palette type. Given row and or at least a set row. Let's call it call instead of calls. It's not a number. It's it's a number, but it is not a static number that's not going to change. It's not a parameter. It's something that is going. It's a variable. It's going to change for. It's just consistent naming convention. We get given call and we'll set the palette type as pty as requested. Well, after that, let's get the position of a particular palette. So let that be a pair for unsigned. Okay, now again. This should be unsigned because it's a coordinate location on our board. Get position get position, simply going to return a pair, or more concisely make pair of row and column. Let's try to see if this still builds. Okay, it doesn't. Better. Let's try to build it again. Okay, does not name a type file. Why doesn't it name a type field? Isn't this the same thing? Okay, probably some spelling mistake again. Right, so what else? Builds just fine.